Yeah, let's see the ATMEGA assembly language program of some more instructions now. So let me give you one example of writing one assembly program here. So here is an example. So state the content of the RAM location. A location is given as 212 and 216 after the following program is executed. So we can actually figure out, okay, what's happening here. So let's look at this. So you have a instruction here. Okay, let me okay, this is done. And okay, so look at this. See, R16 is value is be loaded immediately. 99 is loaded to R16, and then R16 is copied to 0. If you look at 212, so obviously 99 will be the content of 212. Then if you look at this, 85 is loaded to 16, so next location is 213. 213 will get this 85. Then after that, 3F is loaded to R16, and R16 is loaded to 214. That means 214 will contain 3F, and so on. So this is how we can actually decode the instruction and find the working. Let's move on to next one. So state the content of R20, R21 and data memory location 120 after the following program. So here immediate value is loaded 5 to R20, then 2 is loaded to R21. So we will be adding here the number that is, okay, let me just put it in this way. So what we have here is 5 and 2. I'm adding 5 with 21, that means 5 plus 2 is 7, correct? So obviously R20 will have 7, then 7 plus again 2 will be 9. So R20 will have 9, and that 9 is stored to 120. So I should get this answer, correct? So this is how the execution is done. Let me talk about an IO port now. So we will also deal with IO ports. So one thing you make sure here, always there are 3 registers associated here. So this is the one of the register DDRX here. So it's shown here. So you can just find out these, you can get these registers. So one is actually this register DDRX, and then you have port X, and then you have pen register. So these are the 3 important registers when you are actually working on any of this IO port. So I can have, these are the registers, port A I have, and when you are using port A, there are 3 registers associated with this. This will decide the direction. See, DDR-A will decide the direction, and port A decides the output value, pin A decides the input value. Look at the structure of this IO port. So this is the pin that comes out of the IC. This part comes out of the IC, it's called as a pin. So we will be reading the pin using this pin register, that is pin A. It could be when you are dealing with a particular bit, then I say pin A, the dot 7 or dot 6 or dot 5 and so on. And you have a port register where you are sending the output. So when you send here 0, the 0 has to come here. When you send it 1, the 1 has to come here. And when you're reading it, then the read happens through this way. Okay, the read happens through this direction, and write happens through this direction. And apart from that, there is something called as pull up. Pull up is usually, this pin I can actually pull up or pull down depending on the status of this port register. Okay, so what basically we can do here is, so if you put ones into bits of port register, the pull up register is activated. So whenever you make it 1, automatically pull up is activated. Pull up means it is something like you connect a resistor and this is their pin. So this is my pin, this is connected to VCC. So this is the pin. So this is called as pull up. Pull down means you connect it to ground and this won't be there that time. So this is actually pull down. So you are grounding it, this pull down. So basically if you are making this port register high, then it is pull up. When you make this port register 0, then it's pull down. So apart from that, sending the value to any of the port is straightforward as it's written here. And whenever you want to make this port as input or output, then the DDR register is activated. See, DDR register, DDRX means DDR-A, DDR-B, DDR-C. What happens, for example, if you want to make the port as an output, then I should write DDR-A should be loaded with 0xFF. Then all the are becoming as output. If you make DDRA as 0x00, then you are making it as input. That's the difference. So when you are making it as an output, first do this, then you write it the value to the port A. If you are making it as an input, then just write 00 to this and then this register pin B. So these are all the registers that are available for you, like it could be port A. These are the associated register with the port A. These are the associated with port B, and these are all the register with port C, and this is with port D. So these are the 4 different IO ports available here. Now, so what is the difference between in and LDS? So you have seen there is a register called LDS which actually loads the register from a memory. So I can use this LDS, loading the register from a memory. There is one more instruction called in. Actually both does the same operation. I can write an instruction here, for example, in instruction. So LDS is something like you can write, any instructions, for example, LDS. If I'm writing, I have some instructions like, okay, so R16, I write here, R16, 0x 200. Then I'll be loading the content of this 200 location to R16. So this is LDS instruction. I can even work with an instruction in R16. Okay, I can use in R16 instructions. So I'll be loading from a memory. Okay, I'll be loading it from a memory. So I can just use a instruction similar to this. So what happens here, now I have in R16, I should write, okay, which location I want to store or get the value. I can write any register here, but for in instruction I should use a IO register. Okay, so the IO register address is already mentioned. So what are the IO register address? So if you look back here, so IO register address will be it's actually given in my previous slide. IO register address for an in instruction will be for any register. Okay, let's say port B, it is going to be 18. Then what I should write here is R16, 0x18. Then I will be reading port B. I should read actually pin B. pin B register value is say 16. Okay, I will read it as 16 0x16. So pin B I can write here. So pin B value is loaded to 16. So the only difference is this: LDS instruction is a 2-byte instruction, 4-byte instruction LDS, whereas in instruction is a 2-byte instruction. Another difference: in instruction take one machine cycle, and the other one, that is LDS instruction, takes 2 machine cycles. So there is a difference. So, and when you are using in instruction, I can use, instead of 16, I can write it as pin B. That's one of the assembler feature. Okay. So yeah, obvious, the last one is in is available in all AVR. The LDS is not implement some of the AVR. There may be an exception for this. So this is what one of the instructions. So similarly, out and STS is will have a similar structure. Okay. So here is a program to write a program to get the data from the pin B and send it to the IO register port C. So here some insight is given, okay, how things work here. So let me put some more instructions. So here what they want here, like they wanted to read it from port B, that is pin B, and they wanted to send the value to port C. So obviously here the pin B is actually the input and port C is output. So I should configure it. How do I configure? I should write pin B if I want it as input, then DDRB register should be accessed and it should be loaded with the value 0x00. That's what I have told you, that when you write 00 to DDRB, then this is input. Okay, and DDRC should be loaded with 0xFF because 1 indicates output. So all the ports of pins of port B, that is pin B, will be configured as input and port C is configured as output. So once you do this, then we make in instruction and we read the value of pin B to R16, and once we got the value to R16, I move it back to port C for out, and I'll be looping it again. So let me show you this example, how I'm going to do it in uh, the tool that I'm actually using here, the Microchip Studio. Okay, so what I will do is I'm going to change the thing. Let me open the AVR Studio now. So let me take it to this AVR Studio, and here is the window. I'm going to just click here, file, new. You can just click project, then select it as an assembler, and in the assembler code I'm going to put my application as, you can just choose the location where you want it to do. This is the second application I wanted to write. So let me say okay to this, and another window will appear. Here you need to select which family that you are choosing. ATMEGA 328, let me choose. Anything wrong? Yes, ATMEGA 328P, you can select here. This is the one. Just say okay to this, and now its project is getting created. So once your project is created, I have it here. So let me remove all these things. Let me put the instruction one by one that I'm planning. So I said I should load the value that is DDRC. So if you look back the code, so if you go back to the program here, I've loaded DDR-B with the 0x00 and DDR-C with 0xFF. Just remember this, DDR-B with 16. So let me go back to that again. I will go to this tool here. Okay. Now, so I should move, I cannot move directly with the value there, so I should move it to register. So I will use the instruction LDI instruction. Let me turn on the caps lock, this looks better. I will use R16 register to load the value. Any general, R16 onwards you can use 0x00 and load it to, you're going to use a LDS, correct? I'll be using DDRB, comma, I can write it as R16. Is it fine? Then I will write LDI R16, 0xFF. That is what I want to make, LDS DDRC, R16. What I'm going to do now, I'm going to read the value as it is. I will just go back to this and just look at this code here. Yes, I think I supposed to use an out instruction there. So let me use that. I'll go back to this, and so I should use this as out, not LDS, because if I'm using LDS, then I should write the address of R16. Okay, so this should be out DRC. So now what I'm doing here, so this is the value to make. So let me give it here a comment, making a port B as input, correct? And here I'll be making port C as output, and I supposed to read the value. So we have in R16, pin B, I supposed to, because I'm making it as, so read the pin B, that is port B value, because pin B is the register to access port B, and out you're going to give the value to the registers. So if you look back onto this instruction, then out, what else, we're supposed to port C, right? So out instructions should be written. So go back to this code and see out port B, R20. So I'm going to read out port B, okay, I think R20, I can make it R16, not a problem. Let me use a single register, but one thing I made a mistake here is confusion with the problem statement. That is, I'm reading what, okay, I'm reading something else. Yeah, here it is. Port C, out port C, okay, that is out port C. So go back to the code and output C empty. Okay, that's it. So output C are 16. Is that right? So send the value to port C. That's it. So this is what I wanted to do, and this has to loop. I can give some rjump, say wait, rjump, say continue. I can give it here. Continue. Okay, continue should be given over here. I supposed to read it continuously. I think I gave a very long name. Sorry for that. So let me align it properly. Doesn't look good. Okay. So let me save this and build this for you. Build the solution. The build, it will be built. Now you can just go to the debug thing. So I can just click here, debug, start debug and break. Okay, let me see how this will look like. Before I do, I will select what I wanted to do. I wanted to simulate. Just click on simulate and now start debugging, debug and break. So your instructions will stop at the point at this point. So let me take you step by step. So let me create a watch window here for you. Let me watch this R16. Click on this, add a watch. You can see the value one by one. Let me see. R16 loaded, then DDRB should be loaded. You can watch this register as well. Add a watch. You can see here. But I think this is better you watch it on the, okay, this doesn't give you the answer. So I can just show you over here. You have something called as a register window here. 1 second, where it is? Yeah, it's over here. Memory, processor, art, register. Yes. Okay. Not this one. Where is it? Tools. Can have build, debug, project, window. Somewhere I saw. Oh my goodness. Where is it? IO register. Yeah, it's here. So in the IO register, you have some port B here, port C here. Now, if you look carefully here, let me take you to this. Okay, here, yeah, done. So let me see this how it is changing. DDRC, you see here the value will change now. So I made FF here, port C value, and DDRC should be 7F, and why it is not taking, probably it is only the one port. Let me check it. Now let me take the value pin B here. Let me move some value to this. So I will make this pin B as high. Okay, let me make it high, two of the things. And I'm going to watch port C now. Port C is here. Let me see what happens. To loop back, read, and now see here the value has come. So this is the value which supposed to be of pin B. These are the two high, and port C you get the same value which is reflected to pin C. So this is how the value will be read and moved back to the port C. This you can actually make out. So this comes here default. This pin is used for some other purpose. That's why it is not getting activated here. So you cannot do this. So the rest of the things you can see, you can make it high. All these things you can make it high and low. Right. So this is how the things will work over here. So whichever the port you wanted to see, you can do that. Let me take back to the slide over here. Yes. So this is a simple example. Similarly, you have instructions using GPR as an operand. So any general purpose register can be cleared, can be incremented, can be decremented, can be complemented, can be negated, rotate, left, right, all that, swap. I think you can just work out these things with the simple simulator just now I explained you. So here is a simple program to toggle the IO port register continuously. It's a very simple example. Now I'm loading a value to R20, I'm just putting it to port B and I'm complementing it, I'm putting it to again port B and just simply looping it, you know. This will make, you know, the continuous toggle operation. You can simply verify it using your simulator. That can be done. Then you have something called as AVR status register. So we'll continue with this in the next video regarding this AVR. So we'll stop it for a while.